Alright, let's start with chapter 10, question 6. A normal distribution has a mean of 60 and a standard deviation of 3.8. The probability of a score of 56 or less, that's a keyword, is, and they have asked the probability of the frequency. Now, one thing to bear in mind is the Z formula. What is it? Z equals, you all probably know the Z score equals X, that is the raw data, minus mu, which is the mean, divided by the standard deviation. Okay, mean divided by the standard deviation. So where I'll name this, X is the raw data, mu is the mean, and this symbol is the standard deviation. Now, basically we have to use this formula, and also most importantly draw the diagram first of all. That's very important. Your examiner also has stressed this point. If you are to draw the diagram, this side y-axis represents the probability distribution and the x-axis represents the raw data. Now, they have said a normal distribution. Normal distribution means by this mean line, both sides will be divided equally to 50% and 50% each. Okay. Now, they say they have a mean of 60. Therefore, this mu value is the mean should be equal to 60. And the standard deviation is 3.8. That means the gap between this, the way it is spread. You all know that. Now they are asking what will be the probability if the score is 56 or less. You know, if mean is 60, 56 must be somewhere here. Now, if 56 is here, now one thing we should note that the area under the curve is the probability frequency, PFI name. That is what the probability they are asking in the question, the probability of the score. That means they are basically asking the area under the curve. But which area they are asking for? They are asking for 56 or less. That means this part. Alright, this is the area they are asking for. But to find this area, you know that first of all we have to find the entire area's value, this side, and minus this particular area's value. Because why we choose this yellow region rather than this region is because the mean is here. And mean gets naturally first of all connected to number 56. When it gets connected like that, we are able to find the gap, which is the z-score. Alright, I hope you all remember in the tute how we did. So the gap between the mean and the number raw data is the z-score. Because of using the z-score only we can find the area under the whole graph. Actually area of this yellow highlighted area. And then we know that the area under the whole graph is 0.5. So 0.5 minus the z-score will be equal to the small red region over here, which the question is asking. Now let's apply the z-score into question into the z-score. So z-score equals the raw data is 56, right? Minus the mean is 60 as per the question. And then standard deviation they have given 3.8. 3.8. Alright, then what will be the answer? 56 minus 60 minus 4 divided by 3.8 will be equal to minus 1.05. Now, remember the one theory. If z-score is minus, that means the raw data x is below the mean. That means this x value is the raw data I am telling is this 56, isn't it? As per the question. This is less than the mean of 60, no? That's why it is z-score is a negative. But z-score becomes a positive if the raw data is more than 60 over here in this side. Okay, remember that. So if and z when z is equal to 0, z equal to 0, that means what is it? Raw data is equal to the mean. To the mean. That's what they mean. Therefore, having found the z-score, let's go to the normal distribution table. In the normal distribution table, you see, so now you have to search for 1.0526. So, see, you know that we have to first of all pick the number from the vertical axis because the second decimal points part is only in the horizontal line. So, 1 is here and they want 0.5. So you can restrict to 2 decimal places because that is all we can get. So 1.05 is this value, the 0.3531. So the probability distribution of z-score of 1.0526, which is a minus or plus doesn't matter, is how much? 0.3531. This 0.3531 means what? It can be also written as in percentage terms as 35.31 percentage. Now that means which area does it represent in this curve? This 35.31 percentage. We found the gap between 56 raw data and 60 mean. So that means this gap. So if it is this gap, isn't 35.31 this particular gap? Isn't it? It is this area. Right? Only this area. Then if this brown part is 35.31 percentage and if the total of this section is 50 percentage or 0.5, we can write when writing in decimals, then what will be this portion? This portion, it will be 50 percentage minus 35.31 percentage. So 50 percentage, so probability of, so the probability of frequencies below 56 is 50 percentage minus 35.31 percentage. This is equal to 14.6 percentage, 69 or 15 percentage. You see? So the area under the graph, remember that area under the probability distribution graph is the probabilities. Okay. So, and remember, again remind yourself that total area under the probability distribution graph is 1. How it is 1? If you look at this graph, this side is equal to 0.5, this side also equal to 0.5. So 0.5 plus 0.5 equal to 1. And why both sides are 0.5 equally? Because it is called the normal distribution. That is the theory of normal distribution. Alright. Next, let's go to question number 13. So question 13 states, use normal tables to find the value of B such that when the probability of Z less than B is 2%. Now the first step to attempt this question is to draw the diagram. Now they say that probability of Z is less than B. That means we have to actually assume that Z is at the mean point. I told you all previously, when Z is equal to the mean, Z is equal to 0. Okay? When the Z value is equal to the mean, when the Z value is equal to the mean, that means Z is equal to 0. So Z is 0 here. If Z is 0 here, obviously now if it is to see whether B is less than Z or more than Z, we should start from a point to find that. So that point will surely be this 0 point. From 0, whether it is upwards or downwards. But it is downwards, less than. So it's somewhere here. B should be somewhere here. You know this line is the value of Z values. No, it means it has the gap of Z values. Right? So now, if you take the probability of Z, okay, being less than B is actually this part, isn't it? Z is less than B. Now the gap is only Z, no? Gap is Z. This gap being less than B is somewhere here. Right? So this is 2%, they are saying. The area under the graph is 2%. They are asking the value of B. Now, how do we usually get the percentage? Now, first of all, let's fill the gaps. First, this entire curve half is 50%. So, if this part is 2%, this will be 48%. To find the value of B, first of all, we should see what is the value of Z of here. So, the value of Z is, if you go to the normal distribution table, now to get 48% in this particular area, right, it should be, we should look for 48% in this table. It is here. You must, but I told you all during lectures that you should, if something is more than the number we are looking for, we should actually take the number that is less than the number we are looking for, which is 47.98, because after that it is 4803. That's the next. So we want nearly 48%, which can be 47.98%. Now 47.98% comes when at the value of 2 and 0.05. That means minus, now the Z value is only less than D. If you take this diagram, the Z value we have to search for is this z value, because this is only less than this z value, isn't it? So the z value of this particular red zone is 2.05, right? So that means what? If we come minus 2.05 this side, at this point, our value will be 2 percentage. If you think, because this side is 48 percentage under the value of z of minus 2.05. If the z value is minus 2.05 in this area, that only will make this side 2 percentage. Therefore, B will be equal to minus 2.05. Alright, next let's go to question number 14 and then 15. So 14th question says, a company users can use a chemical procedure which changes the values of the mean and the standard deviation. If the standard deviation is set at 35 hours, find the mean lifetime which will reduce the percentage of defectives to 2%. So it is around the same thing. Let's see. So first of all, we should again remember our z-score formula, which is this. The raw data minus the mean divided by the standard deviation. So what they are saying here is the standard deviation is 35 hours. So this is 35 hours. The mean is what we have to find. Percentage of defectiveness 2% is the frequency distribution. That means now the mean we should find true, but the percentage, the difference between these two and division, the z-score is basically not actually the z-score. I would say the normal distribution. Normal distribution is equal to 2%. That this means if you are drawing a normal distribution table, so the standard deviation is 35. And the mean is what we need to find. Mean is right in the middle. The raw data, actually this question they have missed to mention what the raw data is. But in the answer they mentioned the raw data. So we will have to consider raw data as per the answer 40. Now we should find at ND normal distribution 2%, what will be a Z value? If we find the Z value using the normal distribution table, then we can identify the value of, solve the equation to find the value of the mean. Now, so to have a normal distribution of 2%, that means somewhere this percentage, the balance must be 48%. Am I correct? Why did I say 48%? Because this whole part is 50%. So, if the whole part is 50% and what do you call? 2% will be definitely some small portion, no, which is this. Then balance is 48%. Go to the normal distribution table. Now see where you get 48%. You get it here, 47.98. I told you if you should choose the number that is less than the one you are looking for, which is at 2 and 0.05, which is giving a value of z of 2.05 minus. It should be minus 2.05. Why is it? Because they say it is the mean lifetime which will reduce. This word reduce means actually 40 should be over here in the minus section, because They are saying about a -2%. Because why I am saying -2%? Because they mentioned the word will reduce. That's the reason we use -2. Then therefore our z value will be a minus. Because question stated that the normal the percentage defectiveness is reducing. Okay, so therefore find now the mean value. We have all the data, find the mean value. So minus 2.05 equals x is 40 as per the question. Mean we don't know. And that divide by 35 standard deviation. The answer for mean therefore will be 111.75 because we get minus mean is equal to minus 111.75, and then if you divide both sides by -1 you will get plus 111.75. Okay. So with that we finish question 13. 14. Let's next go to the 15th question. Yeah. So 15th question says, central limit theorem states that the mean of the sample is same as the mean of the population. Is it true? No, it isn't. Sample mean is not exactly the same as the mean of the total population because sample will have 5 items. But total population, there may be 10 items. So, will the mean be the same? No, the mean will not be the same in both situations. Therefore, the statement is false. Then what will happen? It will actually, using central limit theorem, the sample mean is approximately. Okay, not exact. The word approximately should be very careful. Approximately means nearly. Approximately the sample of the total of the mean of the total population. Okay, right. So with that, so this statement it becomes false. The answer. So with that we finish a review of chapter 10. Let's move to chapter 11, regression analysis.